Okay. Okay, welcome to AWS News and its new format. What's new that it's in English now includes some pictures, so we can better imagine the actual topic. Today, as usual, we'll go through a new announcement for the last month. And in the second part, Patrick will tell us about his experience with Step Function service. Which is a part of ETL architecture that we built for one of our clients. So the first thing and the most exciting for me personally is SMS Fireform. So SNS is simple notification service, but before we go to this Fireform feature, I would like just shortly to tell about SNS itself, maybe, and differences between pub subsystems and queue systems. So AWS supports both of them, and they both are used for so-called loosely coupled architectures when our components don't depend on each other and just exchange with the messages. So in case of queues, we have producer, we have consumer, and producer publishes messages to the queue, and consumer doesn't receive it immediately. It receives it only when it says, okay, please give me the next message, and so on. So also by default, the order of these messages, which comes from the queue, is not guaranteed. But there is a existing feature from SQS, queue service from Amazon, which allows you to receive the messages in the same order which it was sent before. So if we look at pub subsystems, it works a bit differently. So we also have publishers and kind of consumers, but it's called subscribers. But they receive messages immediately. So usually, like the canonical example is a socket connection, which is established between client and service. And once another client sends the message to the queue to the pub subsystem, the second client, which subscribed to this topic, received it immediately. So now AWS announced that you can have the order for SNS systems for pub subsystems for SNS as well. So what does it mean? So how previously, first of all? So SNS is a very nice thing, for example, to send emails, to notificate some external systems and so on. So it's quite annoying, for example, when your client receives multiple emails, duplicated emails. So this is a really nice feature. That's why I'm exciting. And how can you do it now with SNS? So basically, it's pretty obvious. You can define grouping property for SNS body message. It's called group message ID. And the order which you send these messages having group message ID will be exactly the same for your subscribers. You also can add the deduplication ID property. So Amazon can understand, okay, I had this message already, so it can be based on a hash of your entire body, or it can just look at this deduplication ID. So now you can kind of guarantee that your messages which your subscribers will receive will be in the exactly in the same order, and they won't be duplicated. So yeah, by the way, if you have to discuss it now, otherwise we just will lose the flow afterwards. The second announcement, actually two news about Elastic Load Balancer. Now we have the third type of load balancer, gateway load balancer. It works a bit differently than these two guys, but pretty similar to network load balancer. So this announcement came just yesterday or day before yesterday. It allows you to, it actually satisfies many wishes of enterprises in terms of compliance. So how do you organize, how do you architect your VPC, your private VPCs usually? You have internet gateway, and so basically all your ingress traffic goes through this internet gateway, but you don't have any settings for internet gateway. It's just highly available gateway which passes traffic through. But usually enterprises just need kind of whitelisting, some security configurations, and so on. So basically this gateway load balancer is a replacement for internet gateway, which allows you to set up many security things. The second announcement from Elastic Load Balance is ALB gRPC support. ALB is Elastic Application Load Balancer, and gRPC is API protocol, binary protocol, which is based on proto-buffers from Google. It's efficient, a very nice way to communicate between microservices or between client and server. So this is how gRPC or protobuf API structure can look like. So we define our objects, we define properties, we define types, functions, and then we can embed it to basically to any language. So gRPC has support of many programming languages. So for example, you just write your class in Java, and this class will be converted to this message object, which will be properly sent to the server with some function. So RPC just remote procedure call. So it's completely different thing that HTTP REST. So basically, we used to work with application load balancer as a gateway for HTTP API. Yeah, so it worked natively with very nicely with HTTP. So now you can basically arrange your gRPC API directly from browser with your server. So before you could do it as well. So your microservice components could communicate with each other with gRPC as well, but you might work with HTTP between your client and between Elastic Load Balancer. Now you can do everything with gRPC directly. Lambda and private link, also very nice feature. So now you can call your Lambda function from completely private VPCs, from on-premise VPCs, for example. So before you could assign Lambda to a private VPC, but then it's just private, completely private Lambda. Now your Lambda remains public, and just but your component which wants to call this Lambda is in private network. Now Lambda supports private link, so you basically create this private endpoint link in your VPC, and you attach Lambda to it. So it's basically a kind of gateway. It's based on Elastic Network Interface and row tables, and you can communicate through AWS backbone with Lambda, not going outside to internet. Next nice announcement. So before we had two queue services from Amazon at Amazon SQS and Amazon MQ. So this SQS is more Amazon specific thing. And if you would like to have full-fledged queue service which supports some common protocols and so on, so you would use Amazon MQ. And Amazon MQ supported only one service, so it's basically this open source thing, Apache ActiveMQ. So now came RabbitMQ support. RabbitMQ is very, very popular message broker. So yes, the most widely deployed open source message broker. And of course, as usually from AWS, it's fully managed, highly available, and so on. Yep, so that's it. Next time I would expect much more news and announcements because reInvent event takes place on 13th November for 1 week or so. So this time, of course, online. So I would encourage you to register and take part of it. But now I'd like to give the floor to Patrick.
Okay, thank you, Roman. I'm going to share my screen in about just a second. So there it is. I mean, this is the question of 2020. Can you see my screen?
Yep.
Nice. Okay, so I'm going to talk a bit about AWS Step Functions. I want to go a bit deeper, but first of all, I want to give you a quick overview of what the service actually provides to us and what kinds of things to expect actually. Basically, on the front side, you can already see it's all about these graphs, which should represent a step function as such. And on the other hand, you have a representation as code. So basically, it's all about having state machines. So when you think about state machines, so what I think most of us have learned in uni, it's all about the Coca-Cola drink machine where you can just insert a coin and then the state of this machine in brackets switches, and then you can order a drink, and when it pops out, so you always have a start and an end state, and in between there are several steps that are being taken. As Roman said, AWS is all about the distributed world, so to say. Step functions is another way of combining services to each other. And if you have a look at the service tab and enter a step function, you see that they are actually in their application integration folder. So that's all that holds applications together when you build them up. The next step is I want to show you on quick examples what a state machine looks like and how it functions. Basically, you're actually able to do a lot provided by Amazon. So you can click on create a state machine, and then you have sample projects or templates to choose from. So they are pretty simple, basic examples like hello world. So you have one start state and one end state, and in between you have two states additionally. The simple script, so to say, is represented on this side. So you have JSON, which defines a start state and the states as such. So it starts at hello and passes over to world, right? So you start with hello and the next one is world. So it's pretty saying. Things get pretty complex fast. So if you have a look at, for instance, parallel states, so there's a bit more code to it. But the functionality is pretty descriptive, so to say. So the JSON you're writing is pretty descriptive. So you want to start at the parallel state. You have a state which is called parallel, which is actually of type parallel. So you know that there are sub or branches, they're called, so branches with substates. So there's a huge variety of different types, or basically there are only a few common ones, some more specific ones, and there are some service-related ones. So if we have a look at, for instance, the catch failure, there are some specifics about how to catch an error. If a fail or a state fails, it's automatically catched. So there are some structural things, but this is pretty abstract to explain on this little examples. I want to give you a brackets real world example of what we've built related to a project. So I prepared a state machine, already coded it, and we're going to start it first. So when you're starting a step function, you can insert some parameters to it, so it's able to use them during execution, and you have to provide a name. I'm just going for the defaults now, so I'm clicking on start. And what's happening now is the state machine I defined previously just launched. You can see this in the blue states, and if it switches to green states, something already finished, or a state was run and ended successful. So I'm going to switch to definition, where we might want to have a look at the scripts, but I'm going first of all into more detail of the visual graph, right? So what is happening is we have in the beginning a parallel state. So this is the big, currently blue one. And in this parallel state, we have two main branches. So we have a glue branch. So this is literally glue jobs running, or a streamline which runs glue jobs, but not only the glue jobs itself, but also a crawler. So in the beginning, we want to start a glue crawler. Additionally, we want to check the status of this crawler. And then we want to proceed. I'm going to zoom a bit more in. After we check the status, we're going to proceed to the execution of glue jobs. So this is pretty nice for ETL jobs being done. So when you want to do data loading and you need a tool, so to say, to perform glue jobs in a specific order, and additionally have some other things to be executed. I mean, glue itself provides its own language or scripting type for execution or parallel execution. But for this one, we have another service we wanted to have additionally. So this is going to load something to somewhere from an external data source, which is actually a Lambda function, which is called. So what I want to show you is how this is done, basically. So we have in the beginning the parallel process, just called it full process, right? This is the big one. And then we have a sub branch, which is called glue process. This is this other parallel state. And in here we have our steps where we're invoking lambdas, right? So we have a Lambda function, which is called start crawler. And we hand in the payload a specific, or actually the crawler name. So before the session started, I just set up a crawler, which, I got this name. So I want to hand it over to my Lambda function, and it executes this one. And after that, it continues to check the status of the crawler, right? And checking the crawler status is done by another Lambda function. And this is because the step functions do not provide all resources to be synchronous. Where it is actually provided is for the glue jobs themselves. So you can see here that you have a load job 1 and a load job 2, and then an aggregation job, and they can be asked to be synchronous So we get a notification to our step function when it's finished. This is pretty abstract, but I want to show you what I mean by that. We have an ingestion job, which is our aggregation job, so to say, and we have the or both aggregation jobs actually. So we sorry, both load jobs. There it is. So we have a parallel state for the ingestion jobs, and there's 2 load jobs. And the first loading job is starting up a glue script, and by defining it this way with the start job run.sync, I wait with my step function until it finishes the execution. So I don't have to bother about doing the checks as I did for the glue crawler. So this makes it a bit more elegant to watch the script or the graph, right? And shortens the script definitely. Yeah, well, so when the glue job finishes, everything's fine. Yeah, finally we have a state, so it just ran those jobs live, and when it's finished, we're getting a report that it was successful. On the other hand, we get this error run through, but you can see here that we have this main parallel state. But the error handling is not connected to one of those states. It's actually connected to the state. So we are, in case of an error, we are always going into the glow process error handling, so it's only one thing. Additionally, what I want to present you is how the messages are sent. So it's just finished, and I should be able to tell you live with AWS notifications that we just that our state machine just now finished. So about 5 o'clock. Yeah, it's 5 o'clock. So this is pretty neat. So this is the nice thing about step functions as well. They provide an adapter for the SNS. Publishing, so we can publish our states or success rates or failures to the to specific topic. You have to give up front, of course. And if this happens, everything is fine. And we're done with the step function, right? So this was a short explanation, basically, of the structure. There's one last thing I want to give a quick hint to is the decision state. So of course there's it's basically a state machine. So you can do all the things that are being taught in theoretical informatics. So they're pretty mighty to use, but still with the choice state, there's one special thing about it, which is the bad status received, which leads to nothing, right? So I'm going to show you where this is happening. So we are accessing the output from the previous state. We're doing so by giving the hint to this $sign, right? And asking with, is the state we received from our Lambda function, is it running, stopping, or on the other, running or stopping? And if it's none of those, we actually check whether it's ready. So these are the 3 valid states. And if a state is received, you have the default, and it's just a bad status. So we want to take track of that, right? And the bad status field, I want to go down here. It's just a fail state. So we can actively provide the information to fail the state machine, and it goes into the error handling automatically, right? The good thing about execution being done is we can now track down the history of what was done, right? So interesting should be the switch from the check crawler status to the actually checking the crawler status, right? So we go to the input. So this is the JSON that was provided as an input for this state, so this specific state, and we see we've got something which looks like an answer from a web service, kind of. I mean, we have HTTP headers in here, and this is true because we invoked a Lambda function, if you remember. So this is an answer of a Lambda function which just says, okay, we succeeded, and everything worked. Additionally, we gave you some payload, and the status we provided to you is ready, right? And yeah, the method it works is actually it just dumps, or it just removes the JSON afterwards. So what we've given as an input is not preserved, it's dumped, and we got a new output. So for the check crawl status, it's just passed. But if you have a look at the glue jobs, we get a totally different picture. So we got as an input, we get the answer of our Lambda function. As an output, we get something totally different, which is just what happened during the execution of the glue job, right? So we know, okay, we had a G1X worker type, we had 10 workers running at the same time and everything like that. So it's the configuration that was returned of the job run. And this is handed over to the next job. And yeah, in this output of the job run, right? So we have allocated capacity and the ID is passed over to the next step, right? The output of a state is the input of another state. So this is another thing to worth mentioning. Right, you can always access it by giving hint with the $sign that you want to access the JSON. Additionally, you can give this hint that you want to go for the input that was given to the state. Right, so these are the most specific ones. Basically, that's it from my side. And thank you so far.
Yeah, just a small note. So it was about ETL workflow, basically about glue jobs. Glue service has by itself kind of a way to arrange, organize your jobs, the order which they should be executed, and so on. So it's called glue triggers, but step functions is of course much more flexible and powerful tool. So it's basically suitable for everything. You can attach lambdas, you can connect it with SNS, you can call other services, any service of AWS, basically. So yeah, it's a more powerful way to implement ETL workflow.
Right, yeah. I mean, you can do things like parallelization, so you know that you have two glue jobs that are able to run at the same time. You can do this one as well. And yeah, additionally, having the power to utilize different services at the same time as well. So right, we have on the one hand our glue state, on the other hand we have the Lambda state to check. And yeah, cool. So are there any other remarks or questions from your sides? Okay.
Well, thank you, Patrick. Then
Thank you.
If nobody has questions, I would say that's it, and I will see you next time. Thank you for your attention.
Thank you.
Thank you.
Bye.
Yeah, thanks.
Thank you. Bye.